So let's go back and look at Miami. We talked about it first as having a very large residual. Then when we looked at the residual plot, we could really see how far away it was. So let's see if it's actually an outlier. So this value that we got for Miami, it was giving us this distance traveled of 946 miles, and the airfare was just really high up there compared to what we expected, in that it had an airfare of $350. So first of all, let's just think about why this would be happening. Why would we be getting a higher cost out when we're just traveling this distance of 946 miles? And what we can think about is maybe it's time of year. That can often affect airfares. If it's the holidays, maybe for Miami it's spring break. Generally, airlines know when it's like a popular time to travel, and when it's that popular time, they bump up the airfares. So we just want to be careful. Could also be that they travel like first class or something, so it was a different level of ticket that was used. We don't know, but there are possible explanations for why we're getting an outlier out. Now, if we write down our regression equation and correlation with Miami in the data set, what we had was an equation for airfare that was a 0.1373 times distance plus an 81.7636. And we had correlation of 0.6953, which told us that it was positive and moderate. Now, what we want to do to see if this is an outlier is we want to remove Miami from our data set. And what we'd want to see is, does it change our strength in our correlation? Does it drastically change our equation of prediction? So let's go back to our data set and take out Miami. So in GeoGebra, what we'll do is just delete Miami, and then go through this process of highlight everything, two variable analysis. There's our equation, and let's get out our value for R, which is 0.7888. So our new equation for airfare is a 0.1168 times distance plus 83.3086. And then R is 0.788. So with this, we want to look at two things. Comparing the equations for the lines, has slope changed a lot? Which, no. In terms of our interpretation before, this is a difference in 2 cents per mile, which sure might add up over time, but it's not a huge change. Same thing with the intercept, change in $2, not much in terms of changing a base charge on a ticket. Then what we also want to do is, if our equation for the line hasn't changed much, let's think about our interpretation. So it's still positive, which is good. And then describing the strength, this is still moderate. This would still have a moderate strength. So between the line not really changing that much and our interpretation of correlation not changing, this would not be an outlier. There's no meaningful difference between these two models. So the description didn't change and the equation didn't change that much. So with that, we wouldn't call Miami an outlier. When you would call it an outlier is if this went into a strong association, suddenly it made a stronger data set, then we'd want to call it an outlier. Or if maybe correlation stays very similar, but your equations change completely. If your equations change a lot, then that would show that it's an outlier as well.